Welcome to AI Pulse Trends, your premier destination for deep dives into the latest advancements in artificial intelligence and technology. Today, we embark on an extensive journey into a revolutionary convergence that's set to redefine our digital landscape, AI in edge computing. In an era where data is generated at an unprecedented scale, the traditional model of centralized data processing is being challenged. The need for real-time analysis, reduced latency, enhanced privacy, and efficient bandwidth usage has led to the emergence of edge computing. When combined with the prowess of artificial intelligence, we unlock edge AI, a paradigm that processes data closer to its source, enabling instantaneous decision-making and action. Throughout this video, we'll explore understanding edge computing, its architecture, components, and how it differs from traditional cloud computing. The synergy of AI and edge computing. How AI enhances edge computing capabilities and the resulting benefits. Real-world applications, examining how industries like healthcare, automotive, and manufacturing are leveraging edge AI. Technical insights, delving into the hardware and software that power edge AI. Benefits and challenges. A balanced view of the advantages and the hurdles in implementing edge AI. Future outlook, predicting the trajectory of edge AI and its potential impact on various sectors. Whether you're a tech enthusiast, a professional in the field, or simply curious about the future of technology, this video aims to provide a thorough understanding of AI in edge computing. Let's embark on this enlightening journey together. Understanding edge computing. To grasp the significance of edge AI, it's essential first to understand edge computing. What is edge computing? Edge computing refers to the practice of processing data near the edge of the network, where the data is generated rather than relying solely on centralized data processing warehouses. This approach minimizes the need to send vast amounts of data back and forth between the source and centralized servers, thereby reducing latency and bandwidth usage. Key components of edge computing: edge devices. These are the devices that generate data. Examples include smartphones, IoT devices, sensors, and more. Edge nodes or gateways. Intermediate devices that process data from edge devices before transmitting it to the central servers or cloud. They can perform data filtering, aggregation, and even some level of analysis. Edge servers. Localized servers that handle substantial data processing tasks, reducing the load on central servers. Central data centers. While edge computing emphasizes local processing, central data centers still play a role in tasks that require significant computational power or long-term storage. How edge computing differs from cloud computing. Traditional cloud computing relies on centralized data centers to process and store data. While this model offers scalability and robust processing capabilities, it often introduces latency due to the distance between the data source and the data center. Edge computing addresses this by bringing computation closer to the data source, enabling real-time processing and reducing the strain on network resources. Advantages of edge computing: reduced latency. Processing data closer to its source means faster response times, crucial for applications requiring real-time feedback. Bandwidth optimization. By processing data locally, only essential information is transmitted over the network, reducing bandwidth consumption. Enhanced privacy and security. Local data processing minimizes the exposure of sensitive information over networks, reducing potential security risks. Operational efficiency. Edge computing allows for decentralized processing, leading to more efficient system operations and reduced dependency on central servers. Challenges in edge computing: infrastructure management. Deploying and managing numerous edge devices across various locations can be complex and resource-intensive. Data consistency. Ensuring data consistency across edge and central systems requires robust synchronization mechanisms. Security concerns. While local processing enhances privacy, edge devices can be more vulnerable to physical tampering and localized cyber threats. Geeks for geeks. Understanding these facets of edge computing sets the stage for exploring how integrating artificial intelligence amplifies its capabilities, leading us into the realm of edge AI. The synergy of AI and edge computing, continued. What is edge AI? Edge AI involves deploying AI algorithms directly onto edge devices, enabling data processing and analysis to occur locally, at the point of data generation. This integration allows devices to make intelligent decisions without the need to send data back to centralized servers. By combining artificial intelligence with edge computing, we can achieve a variety of benefits that were previously unattainable. How AI enhances edge computing. The addition of AI algorithms enables edge devices to not only process data but to analyze it in real time, make predictions, and take autonomous actions. Here's how AI boosts edge computing. Real-time decision-making. AI empowers edge devices to process and analyze data as it arrives. For instance, a camera with AI can analyze visual data on the spot to detect anomalies or identify objects. In autonomous vehicles, AI processes sensor data in real time to make driving decisions on the fly, minimizing the risk of accidents. Predictive analytics. Edge AI can predict future events based on data received from sensors or devices. In industrial settings, predictive maintenance algorithms can identify when machines are likely to fail, allowing for timely intervention and preventing costly downtime. Reduced latency. One of the most significant advantages of Edge AI is the latency reduction. With traditional cloud computing, data must travel to a data center for processing, which introduces delays. Edge AI eliminates these delays by performing computations locally. This is critical in applications where speed is essential, such as healthcare diagnostics, autonomous systems, and robotics. Improved privacy and security. Since data is processed locally, there is less need to transmit sensitive information over networks. This not only enhances privacy, but also reduces the risk of cyber threats associated with data transmission. AI models can also detect security threats in real time and take actions to prevent breaches. Efficiency. With AI at the edge, devices can filter and pre-process data before sending it to central servers or the cloud. This leads to more efficient use of bandwidth, as only essential data is transmitted, reducing the load on networks and improving system efficiency. Real-world applications of Edge AI. Now that we understand the synergy between AI and edge computing, let's dive into some real-world applications that are benefiting from Edge AI. Autonomous vehicles. In autonomous vehicles, AI processes data from various sensors like cameras, radar, and LiDAR to make decisions on the spot. For example, object detection, detecting pedestrians, vehicles, and obstacles in the vehicle's path. Decision-making, making driving decisions, such as braking or accelerating based on real-time data. Mapping and navigation, continuous updating of maps based on data received from sensors to adjust the vehicle's path. Edge AI allows these vehicles to make split-second decisions with minimal latency, which is critical for safety. Healthcare and wearables. Edge AI is also transforming the healthcare industry. Wearable health devices. AI-enabled wearables like smartwatches can monitor heart rate, blood pressure, and even detect irregularities like arrhythmia in real time. Processing this data on the device itself minimizes latency and improves patient safety. Remote diagnostics. In rural or under-resourced regions, AI-powered devices can diagnose conditions using local data processing, allowing healthcare professionals to make quick decisions without relying on centralized cloud systems. Medical imaging. AI models can analyze X-rays, kinetic scans, and other medical images locally to detect diseases like cancer, reducing the time it takes for doctors to receive results. Smart cities. Smart cities rely heavily on real-time data to optimize urban living. Here are a few applications. Traffic management. AI-powered traffic cameras at intersections can analyze vehicle flow in real time to adjust traffic lights for smoother traffic. Waste management. AI sensors in waste bins can detect when they are full and notify waste management services to collect trash on time. Surveillance and security. AI cameras monitor public areas for suspicious activity, identifying potential security threats or accidents in real time. Edge AI enables these systems to operate autonomously and efficiently, making cities smarter and safer. Industrial IoT, IoT. The industrial sector has benefited immensely from Edge AI. Predictive maintenance. Industrial machines are equipped with sensors that collect data on their health. AI models process this data at the edge to predict when a machine is likely to fail, allowing maintenance teams to address issues before they result in downtime. Real-time monitoring. AI models monitor the performance of manufacturing processes, ensuring quality control and optimizing efficiency. Supply chain management. Edge AI tracks inventory and predicts supply chain disruptions, enabling companies to respond quickly to changes in demand. Edge AI helps industries save costs, improve efficiency, and reduce downtime. Technical foundations of Edge AI. To make Edge AI work, several key hardware and software components come into play. Here's a breakdown of the technical foundations. Hardware for Edge AI edge devices. These include smartphones, wearables, sensors, cameras, and other devices that collect data. Edge gateways. intermediate devices that process and filter data before sending it to cloud servers, such as the NVIDIA Jetson Nano and Intel Movidius. Edge servers, local servers, often housed in micro data centers, that handle more complex computations and store large data sets for processing. Specialized AI chips, devices like the Google Coral Edge TPU or NVIDIA Jetson Xavier are designed to run machine learning models at the edge, providing the computational power needed to process data locally. Software for edge AI machine learning models. These models are often trained in the cloud and then deployed to the edge for inference. Popular frameworks for edge AI include TensorFlow Lite, PyTorch Mobile, and ONNX. Edge AI frameworks, platforms like Edge Impulse and AWS Greengrass allow developers to build and deploy machine learning models specifically for edge devices. TinyML, Tiny Machine Learning, TinyML, involves deploying machine learning models to devices with limited computational resources, such as microcontrollers. The combination of efficient hardware and software tools makes edge AI possible and scalable across various industries. Benefits of edge AI. Edge AI brings numerous benefits to organizations and industries that adopt it. Here are some of the most notable advantages. Speed. With data processed locally, edge AI reduces latency, enabling faster decision-making. This is particularly crucial for applications like autonomous driving, robotics, and real-time monitoring. Bandwidth efficiency. Only relevant data is sent to the cloud or central server, reducing the strain on networks and improving bandwidth efficiency. Security and privacy. By keeping data local, edge AI enhances privacy and security. Sensitive information doesn't need to travel across networks, reducing the risk of data breaches. Autonomous operation. Edge AI allows devices to function independently, even in the absence of a reliable internet connection. This is especially important in remote areas or in applications like drones and autonomous vehicles. Cost savings. By reducing the amount of data transmitted and minimizing the reliance on cloud-based processing, organizations can lower their operational costs related to data storage and network bandwidth. Challenges of edge AI. Despite its many benefits, edge AI does come with its challenges. Hardware limitations. Edge devices have limited computational power, memory, and storage. This can make running large, complex AI models difficult, although techniques like model compression and pruning help mitigate this. Data synchronization. Keeping data consistent across distributed edge devices and cloud systems can be a challenge, especially when devices are operating autonomously. Security threats. Edge devices are more vulnerable to physical tampering and cyber attacks since they are often deployed in less secure environments. Scalability. Managing a large number of edge devices spread across various locations can be complex. Ensuring consistent software updates, monitoring, and maintenance is essential. The future of edge AI. The future of edge AI is incredibly exciting. As technology continues to evolve, we can expect further advancements in both hardware and software that will expand the capabilities of edge AI. 5G and edge AI. The advent of 5G technology will provide faster, more reliable communication networks, enabling edge devices to work even more efficiently. Federated learning. This approach allows AI models to be trained across decentralized devices without sharing data. This is particularly important for industries like healthcare, where data privacy is paramount. AI at the nano edge. Smaller and more energy-efficient devices will bring AI to even more constrained environments, such as wearables and implantable medical devices. In conclusion, AI in edge computing is one of the most transformative developments in technology today. By enabling real-time data processing closer to where data is generated, edge AI is revolutionizing industries, improving decision-making, and enhancing privacy and efficiency. As we look ahead, the fusion of AI with edge technologies will continue to drive innovation across various sectors, from healthcare to manufacturing and beyond. If you found this video insightful, don't forget to like the video and subscribe to AI Pulse Trends for more deep dives into AI and cutting-edge technologies. Drop your thoughts and questions in the comments below. We'd love to hear your perspective. Share this video with anyone who's interested in the future of AI and edge computing. Thanks for watching, and stay tuned for more exciting insights on AI and technology.